Hello, everybody. Welcome to Unit 3, 3.1. This is where we actually start beginning to talk about real statistics, which is really nice. And it's kind of gonna set the tone for the rest of the year as well in terms of how things should look. So we've got these guided notes that we're looking through. We're just gonna talk about them, and yeah, we'll just give you everything that you need to know for 3.1 statistics, the science and art of data. What is statistics basically is what we're going to cover today. So the science and art, so it's kind of a definition, right? The science and art of, let me zoom in on some of this so I can write this in a little better. Collecting, usually I can write stuff better. Collecting, analyzing, and drawing conclusions from data. Basically, long story short, you go out in the world and collect data. It can be through a survey, it can be through some sort of experiment, but you go out and you collect some data about something that you're researching. You analyze that data. What is that data telling you? Uh, and then you can draw conclusions from that data. Oh, this is happening in this place, or this survey tells me that this candidate might win the election, or whatever the case may be, right? But you collect data, you analyze it, and you make a conclusion about it. It's very sciencey, if you will. Very much sounds like a science process, right? So statistical problem solving process. Speaking of which, step 1 is ask questions. Hey, what do I think is happening here? Or what do I think people think about this? I wonder if I'm just trying to think of examples, but like, if you're wondering something like, hey, I wonder if who's gonna win class president, or who's gonna be homecoming queen, right? You can ask those questions, and you can, start to think about like making a survey and finding out answers to that and getting polls and analyzing your data. But it all starts with asking questions is what is it that I'm interested in? What can I find more data on? Step 2 is collect the data. So collect data. Go out there and find a way to collect data. Again, it could be through some sort of experiment or through some sort of survey or poll. Step 3 is analyze data. Analyze data. And step 4, interpret results. So we're obviously throughout the year going to do this ourselves many times, and so you'll kind of get the gist of it through that. But yeah, basically come up with a question that you're curious about, collect the data, look over the data, and interpret the results. What conclusion can you make from what you've discovered or pulled in your data? So now an individual. Individual, um, individual is a person, animal, or thing described in a set of data. So a person, animal, or thing described in a set of data. A variable, any attribute that can take different values for different individuals. Um, so like let's say you're researching the summer movies, like, oh, I wonder what's one of the more popular movies out there. Well, so one way you could measure that is by opening weekend money, and you can see that it's going to be down here as well. And so that's a variable because that's going to have a different result for different individuals. Your individuals would be like your different movies that came out, and the values would be like how much money they made the opening weekend, and that's one of the variables. So we'll talk about that in a second. Two types of variables: categorical variables and quantitative variables. Categorical take values that are labels. Think about categories, right? Labels, categories. things that you can kind of like a color. I'm trying to think color, favorite sport, favorite pet, things that you can label certain type, right? Which place each individual into a particular group or called a category. Yeah, group called a category. The other type variable is quantitative. Now this is more numerical. So it takes number values that are quantities, counts or numerical values. Counts or numerical values. So this would be like things like heights, weights, calories eaten for a meal, things like that. Anything that could basically be quantified with some sort of value or amount. So those are your two types. So let's look at an example. It says here the website boxofficemojo.com lists the widest opening domestic. I don't know what it means by widest, but opening domestic PG-13 movies of all time. And there's definitely a typo in here, but it's okay. We'll just deal with it. Measured by the number of theaters. The table displays some data for the top 5 widest opening of all time, as reported during a recent year. So this is so the question was, hey, I wonder what is some of the most popular PG-13 movies of all time. That's our question, right? If you're going back to this process here. Then you collect data. So what this person's done is they've gotten some individuals and they've collected data as to number of theaters played in, distributor, opening weekend gross, and then genre of movies well. So they've got several different variables that they've collected their data with. So these are the 5 individuals, and these are the variables recorded. Analyze the data. Well, that's what we're going to do next, right? So potentially. So identify the individuals and variables in this data set. That's A. So the individuals are the 5 different movies. And the 5 movies. So essentially Avengers. I'm not going to list them all out. It's going to take too long. Avengers. Hold on, it's a little laggy. Give it 1 second. There it goes. So what did I say? Avengers. Spider-Man. Jurassic World. Can't spell some of these movies. That's supposed to be an R. But anyway, Jurassic World. It's hard to write on this, especially this early in the morning. Avengers again. And Twilight Saga. Twilight Eclipse. Twilight Eclipse. So those are the 5 individuals, 5 different movies. Ooh, jeez. Just put my leg up and I kicked the desk, but don't worry about it. All right, B, classify each. Oh, we didn't do the variables yet. Those are the individuals. The variables, gotta mention those too. The variables, let's put that in red so it kind of stands out a little bit differently. The variables are the top, you can see them on the top line, the theaters, distributor, opening weekend gross, and genre. All right. Classify each variable as categorical or quantitative. Okay, we can do that. So, let's go ahead and list out these. So the variables were theaters, We had a distributor. We had opening weekend gross. And we had genre. So we're going to label these as categorical or quantitative. So theaters. This is the number of theaters that it was played in. This is numerical in value. So this is quantitative. Quantitative. Anything that's numerical is going to be quantitative. You can just think of that. Can't be quantitative if it's not a number. Distributor. So the distributor, notice it's not quantity, it's a category. Walt Disney, Sony, Universal. These are categorical. They're categories. Yeah, they're labeled. So again, not numerical is essentially going to be categorical. Categorical. Opening weekend gross. Obviously, this one's numerical. So this one is quantitative. We can quantify how much money they made. Quantitative. And then genre. Again, another categorical one because it's a category of movie. It's another label. So categorical. All right. Very nice. All right, flipping it over to the back side now. We have a bonus tip. Says categorical variables can take on numerical values like house number, telephone number, social security number, and zip codes. None of these are count or measurements, so they are not quantitative. So that's an important point. So think about like a zip code, for example, right? What are we in this? 33544? Is that our zip code? Something like that. I know Land O'Lakes has like 34639, 34637, so stuff like that. Those zip codes are, even though they're numbers, they're still a categorical thing because it's not quantifying anything. It's not counting anything. It's not measuring anything. It's basically just a name of an area of land, right? And if it's still a name of an area, then it's still a label for that area. So it's not, again, don't just think everything that's numerical, or not everything that's a number, I should say, is quantitative, because it's not. Zip codes as well, right? Or not zip codes, area codes like 813 or 727. They don't count anything. They don't quantify anything. They're just a number that represents an area people have their phone. So, social security number, again, that's it's not counting anything, it's not quantifying anything, it's just a label attached to your person, right? Just in number form. So those are all categorical, even though they're numbers. So don't just think, oh, it's a number, so it's quantitative. No, it has to actually quantify something to be quantitative. All right, distribution. Tells us what values the variable takes and how often it takes those values. So you can make a distribution right now of the people in the class and how many pets they have. So one person might raise their hand and say, I have 4 pets. Another person might raise their hand and say, I have 7 pets. Right? And then someone else has 4 pets and someone else has 7 pets. So you can make like a little bar graph sort of thing of, the bars will be how will be as tall as the people of who have them. So if like, 9 people have 4 pets, then you'll see a bar that goes up to 9, right? On the number 4 for number of pets. So distribution, think of like a bar graph, essentially like that. Or what we'll do is a histogram. We'll talk about those coming up in the future. Frequency table shows the number of individuals having each data value. Number of individuals having each data value. We've seen this essentially before, but it's just a table. A table. We'll make them down here, so you'll get the gist of it. And then lastly, relative frequency table. So it's the same as a frequency table, but it breaks it down into a percentage. So it shows the proportion or percent. Proportion or percentage. I'll just write percent. of individuals having each data value. So it can take the numbers from a frequency table and convert them into a percentage or a proportion. And we'll see that in this example here. So last thing we have to do today is we have our data here. It says below are the data on preferred movie genre from a sample of 40 teachers. So this is the data that was collected, right? We asked 40 teachers what their favorite movie genre is, and these are their 40 responses. So now we're going to essentially quantify them, right? So summarize the distribution of preferred movie genre with a frequency table and relative frequency table. So if we look for action first, you'll see we could circle them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 that favor action. So this is going to be just the counts, essentially. The frequency table is just going to be our counts. Okay, just original counts. Okay, the frequency table. So those are the action. Let's pick another color. Let's look for animation. So animation, there's only the one right here, one animation. For comedy, there are, let's see, 1, 2, 3, 4, 5 comedy. And you get the gist of it, but let's go ahead and fill in the rest. So documentary, we have 2 for documentary. Drama. What would the green? Do like a lighter green. Drama. Let's see here. 1, 2, 3, 4, 5, 6. 6 for drama. Let's see. Horror. Oops. Horror, we have 1, 2, 3, 4, 5, 6. We have 6 for horror. And running out of colors here. Rom-com and sci-fi. So rom-com, 1, 2, 3, 4. 4 for rom-com, and there's also, I believe, 4 for sci-fi. 1, 2, 3, 4. Yeah. So if you want to just double check, these should add up to 40, right? Our 40 individuals. But this is our frequency table. It's basically just a count table, right? We count how many of each type there were from the data. Now we're going to make a relative frequency table, which is going to turn these into proportions or percentages. So basically, to start, we had action, right? Action was 12 people, but 12 out of 40. So let me change this back to blue, maybe. So 12 out of 40, which as a proportion is 0.3. As a percentage, it's 30%. So you could write it as 0.3 or 30%, either is fine. Animation was 1 out of 40. So that's a very low number. It's 0.025 or 2.5%. Comedy, 5 out of 40. 5 out of 40, which is 0.125 or 12.5%. Documentary, 2 out of 40, or 0.055%. Drama, 6 out of 40, which is 0.15 or 15%. We also had another 6 out of 40 for horror, so same thing, 0.15 or 15%. And 2 more. Rom-com, we had 4 out of 40, which is 0.1 or 10%. And also sci-fi, 4 out of 40, same, 0.1 or 10%. All right. So this chart, you could just leave it with the decimal values, the proportions, or the percentages. It doesn't really matter. Either way, if it's a proportions or percentages, it's going to be a frequency table. So I kind of just included both just to be super duper thorough. But yeah, it could be technically just either. You don't really need both of them there. Just remember that the proportions, these decimals should all add up to 1. If they didn't add up to 1, something's going to go wrong. But those should add up to 1, and the percentages should add up to 100, right? Percentages should add up to 100. So that's going to do it for the 3.1 notes. Hope it helps, and I will see you guys in class. See you on the next one. Bye for now.